Welcome back to the second video for week 4. In this video, we are starting a new chapter. We are going to talk about consumer behavior. We started this course with an example of a apartment owner who would like to rent 5 of his apartment, and we talked about the different possible probable renters and their reservation price, and through that we derived their demand function for apartment in the market. So, we figured out that demand function is a downward sloping curve, and heuristically we discussed why demand should be a downward sloping curve. In this chapter, we are going to study consumer behavior, and systematically we are going to obtain demand function for each consumer, and from each consumer we can add them up and we can get the demand function for the market. If you also remember, we started talking about producer, and from a producer we got his supply function. Of course, we had many restrictions that when can we get that supply function, when that producer is price taker not only in input market but also in the output market. We will take that things again in due course, but meanwhile let us talk about consumer behavior. I will also do one more thing. As we have seen many concepts for producer side, many of those concepts are applicable in the same form or slightly altered form for consumer behavior. So, I would also be mentioning that the similarity and differences with producer when it comes to consumer behavior. So, let us dive into the building blocks of consumer behavior. How to talk about consumers? When you are doing engineering, life is very simple. You come up with a physical model, and that physical model can help you understand. For example, you want to understand drag coefficient on a car. There are two ways to go about it. One, you make a replica, a scaled down version of exact car and put it in the wind tunnel facility and see how much is the drag coefficient, and then use mathematical formula to get it for the actual car what would be the drag coefficient. That is one way. The second way is that you build a mathematical model, use computational fluid dynamics on that mathematical model and obtain your drag coefficient. So, we are doing something like we have the second approach. We are going to build mathematical model of consumer. I should warn you right in the beginning that it is not like all consumers follow these laws or these assumptions that we are making. In fact, these are not laws because they do not follow it, but I will give you the reason that some of these basic assumptions, if a consumer does not follow, we cannot talk about his or her behavior in systematic manner, and therefore, for all meaningful decision from consumer has to have some systematic pattern, and we are trying to figure out that systematic pattern through this and some of the forthcoming videos. So, let us talk about building block of the model that we are building for any consumer. So, the first building block is consumption possibility set. So, let us understand all these terms. Consumption is about eating, using, utilizing any of the good. What is a good? Good is something that gives us satisfaction, happiness, of that sort of thing. Okay. So, here for example, you are consuming this video. It is not always about eating, it is about grasping, it is about something that gives you satisfaction, that gives you happiness, that gives you some utility. That is what consumption is. Possibility is that think about all the possibility, what you can fathom, what you can think. So, in reality, we may not be able to have 5 Mercedes car, 2 BMW car, 1 Ferrari car, but we can at least imagine, so they will become part of our possibility. And set is a combination of all the bundles that can be used. So let us look at it mathematically speaking, that we have n different goods, 1, 2, 3 to n. These are the n different goods, and n is a any integer, can be very high integer, can be in millions, can be in crores, can be in hundreds of crores, that does not matter. And the amount of good 1 that this person consume is x1, amount of good 2 that this person consume can be denoted by x2, the amount of good 3 can be denoted by x3, and so on, we have xn. So, we can put it in the bundle form, and rather than saying every time that it is for the first good, it is for the second good, we will assume that they are in order. So, if ith item represents the consumption amount of ith object or ith good, that is what we can say. So, we can say that consumption set is collection of all these n tuples. N tuples is a mathematical word that indicates they are in an order and they have n different elements. So, it is combination of this all n tuple, and we will talk about it little bit more. So, from possibility, and why we are allowing everything which is not fathomable today, but not, but we can imagine but really cannot consume it, because we want a set that is universal. So, even if our financial situation changes, still we can use that set, and that is why it includes everything that you can imagine. From possibility we move to feasibility, and we will come back to all these points and discuss them in detail. How feasibility is different from possibility? So, one reason could be that something is not feasible as we do not have an adequate amount of money. So, that is how feasibility is different than possibility. In possibility, we can think about it, we can fathom, we can imagine, therefore, that particular item would be part of our possibility set, but not in feasibility. Feasibility, we have to consider the reality of life. It can be financial, legal, geographical, or anything. So, all these are about bundles. Now, from bundles we will move to preferences, and we will talk about preferences in detail, but preferences are something that you go to a friend's place and the friend offers you that would you like to have tea or coffee. Here you do not have any financial consideration, you are not considering the price of tea or price of coffee. You would say tea, that I would prefer tea if you like tea more than coffee, or you would say coffee if you like coffee more than tea, or you can say I do not care, as you are indifferent between tea and coffee. So, we will talk about preferences, they are very important, and then we will talk about a behavioral assumption which will look very obvious to you, that's that assumption is very obvious why you need to assume it. But as I gave you an example of a car, when you are building its mathematical model, then everything needs to be spelled out very clearly. So, in that aspect we will, the way we are building the model, we need to spell out all our assumption, all our building blocks clearly. So, we will talk about that behavioral assumption. So, let us quickly talk about consumption possibility set, and then we will spend a lot more time on consumption feasibility set. So, in consumption possibility set we have bundle, we can say consumption possibility set is X. What does X contain? Let us say that X is n tuple, which is equal to x1 to xn. It gives amount of all these n different goods. We can say X is an element in consumption possibility set. By mistake I said production. On production side exactly you have production possibility set, and production possibility set gives the different combination of input that can give you particular amount of an output or different outputs, and that all will be part of production possibility set. Similarly, we have here consumption possibility set, and I told you there are many similarity on both sides. So, this is consumption possibility set. So, we can say it is in non-negative orthant. What does it mean? In two dimension we can see that if you have x1 here, x2 here, x1 is positive, x2 is positive, but here x1 is negative and x2 is positive, here both are negative, and here x2 is negative but x1 is positive. So, this is the positive quadrant because we have just 4. So, that is why I can call it quadrant. It is both are non-negative in this zone. So, we are concerned about this only. We will not use this, we will not use this, and we will also not use this. When we have n tuple, we talk about non-negative orthant. What do we mean? That xi is greater than or equal to 0 for all I. So, we are not consuming negative amount of any item. How is it so? Let me give you an example, and that you may want to consume negative amount of it. Let us say pollution. You would like to consume less and less of it. So, what we can do in our setup, pollution is anyway not a good, it does not give us satisfaction, in fact it takes away satisfaction from us. So, we can call that pollution is a bad that we would like to avoid, and we can come up with a new entity which is minus pollution, and this becomes good because minus, and then it also becomes positive, then that is what we are interested in. So, we are interested in positive orthant where all individual items are in non-negative number. Why I am not saying positive orthant? Because when we say positive orthant, we will exclude a bundle in which all elements are, all items are present in 0 amount. We do not want to do that. We want this to be included in our consumption possibility set. So, we can say consumption possibility set is X such that if x belongs, small x belongs to x, all xi's are greater than or equal to 0 for all I. That is one condition that we have, and that is what we are talking about here. Second, we can say X, capital X consumption possibility set cannot be empty. Of course, it is a very mathematical thing to say, but the idea is that we are imaginative enough that we can conjure of different bundles that should be included in consumption possibility set. We cannot say no, there is no bundle, that is impossible. That is the second assumption. The next assumption is first, rather than talking about convexity, I will talk about additivity and divisibility. What is additivity? Let us say we live in a world in which we have only 2 goods, and many times we will talk about 2 goods world, and later on I will also give you a logic that why it is good idea to limit ourselves to 2 good world. It helps us tremendously. So, there are 2 goods only. So, let us say x11 comma x21 is a bundle in X, and let us say x12 and x22 is another bundle in X. So, additivity says that if you are able to, let us say we can call it x1 bundle, we can do superscript because subscript is reserved for the first item, that x1 bundle is an element in X and x2 bundle is an element in X. What it means that you can also think of, you can also imagine that they are sum. Basically what you are saying, let us say good one is your cloth and good one is food. If you are able to think of one unit of cloth and 2 unit of food and 2 unit of cloth and 1 unit of food. So, you must be able to think about 3 units of food and 3 units of cloth by adding these two, vector addition. So, it is a very simple innocuous assumption, it does not create any problem. Next assumption is of divisibility. What is divisibility? This is little bit more troublesome. Divisibility is that if you are able to think about x1 in x, then you are able to think about alpha x1 in x, where alpha is any element between 0 and 1. So, it means if you are thinking of 1 comma 2, you are also able to think of half comma 1, or you are also able to think of 1 by 3 comma 2 by 3. Here we have used alpha is equal to half, here I have used alpha is equal to 1 by 3. The idea here is that you are anyway imagining things, you are thinking, you are fathoming, you are what are the possibilities. In reality, sometimes it may not be possible to consume half a car, but I already gave you example that when we are talking about consuming a car, what do we mean? That having the car service for a one full day, that can be the unit, or can be unit could be that one car service for one whole month. And then it is possible, given the market, let us say that taxi walas are able to rent car for on daily basis, then at least you can have alpha equal to 1 by 30, 2 by 30, 3 by 30, 4 by 30. Here also you do not have all alphas, but you can play with time scale and you can try to fulfill this divisibility requirement. That this is way more difficult than additivity, because at some level further division is not possible. But assuming this divisibility really helps us with mathematics, and therefore we assume it, and most of the time it is able to give us good approximate result, and therefore we will also assume divisibility. And if a set satisfies additivity criteria, what do we mean? Additivity criteria, that if small x in x, y in x, the additivity says that x plus y is in x. And divisibility is if x is in x, then alpha x is also in the capital X, where alpha is between 0 and 1. So, we say that if additivity and divisibility are satisfied, then convexity would be satisfied. So, let us look at convexity in slightly more detail. It is a very useful mathematical property and we use it again and again. To understand convexity of a set, let us take a set X, and this X is not conjunction possibility set, X can be any set. Let us say this set is like this, okay, and it has 2 points. Let us say the 2 points are X and Y, any 2 points. And when we draw a line connecting X and Y, there are 2 possibilities. In this case, it is completely within the set, you know. If we had a set like this, let us say set like this, and we take X here and Y here, what would happen? If we connect X and Y, the line is not completely within the set. So, when we have a set such that any 2 points, for all 2 points in that set, if we draw a line between those 2 points, it is completely contained within the set, then we call that set a convex set. What does it mean? Let us understand. Here lambda can be any number between 0 and 1. So, how can we indicate a line that passes through X and Y? That is coordinate geometry, and that line has this equation Lx plus 1 minus lambda y, where lambda can be anything between 0 to 1. We can check. If lambda is equal to 0, this becomes 0, this becomes 1. So, you are left with y, you have this point. If lambda is equal to 1, then you are at this point. If lambda is equal to half, then you are exactly at the half point in the middle. So, if this is completely contained in x for any x and y, here you can take x and y, let us say now you say A and B, it is completely contained within the set. But can we call this set a convex set? No, because there exist two such points x and y. When we draw a line through them, it is not completely, that segment that lies between x and y is not completely contained within the set x, and therefore it is not convex. Here it is convex. So, let us say that additivity and divisibility assumption will give us convexity, because if x can be consumed, any lambda x can be consumed, where lambda is between 0 to 1, and if y can be consumed, any 1 minus lambda y can also be consumed. Why 1 minus lambda y can be consumed? Because divisibility assumption says here 1 minus lambda is between 0 and 1. So, divisibility assumption would allow that, and because this can be consumed and this can be consumed, so additivity would say that this can also be consumed for all lambda between 0 and 1, and that is why convexity assumption gets satisfied whenever we have additivity and divisibility. I just want to say that that is also an important assumption for production possibility set, although we did not discuss, but let us say that there is a production possibility set. We have that x1 can be used to produce y, and there we do slightly different way. We can put a minus sign here, because as it is getting consumed and this is getting produced. So, minus keeps track of what is getting consumed and what is getting produced. If x minus x1 can produce y, then and minus x2 can also produce y, it means that minus x1 plus minus x2 should be able to produce 2y. The idea is very simple: produce y using x1 and produce y here using x2, you get 2y, you end up consuming minus x1 x2. So, additivity is satisfied. And for constant return to scale, we can say if this is possible, then minus lambda x1 comma lambda y is also possible. But this is again problematic, that you cannot divide production process infinitely. So, that one has to be careful about, one has to look into it, but nevertheless this is the assumption which makes our life really simple. So, we are going to stick to this particular assumption. Okay. So, in the next slide we are going to start discussing consumption feasibility set. So, once we move from possibility to feasibility, we may have to face certain constraint, like one can have legal constraint, certain items they may give us pleasure, but may be banned by government. Like in India, sometime many books get banned, many items get banned, you cannot consume them. So, we could have legal constraint. There could be geographical constraint, like I am located at IIT Kanpur, and let us say that even if I have money, I do not have money, but let us say even if I have money and I am interested in buying Ferrari car, there is no showroom in Kanpur to which you can go and buy such a car. So, you can have geographical constraint, items may not simply be available in your geography. And then there would be financial constraint, that of course one can imagine watching expensive cars, expensive mobile, expensive items, but you may not have enough money to purchase those items. So, you may have to face financial constraint. So, we come up with a set, let us say a consumption feasibility set, and let us denote it by y. We say y is a subset of consumption possibility set such that items in y are possible or are feasible for you to consume, are feasible for you to consume. We are talking about a particular consumer. So, this is what we are talking about. But although I talked about legal constraint and geographical constraint, I am not going to focus on these constraints largely. I will focus on financial constraint. Financial constraints are really useful. We can do some jugglery and take care of legal and geographical constraints. Let us say that if a good is simply not available in your locality, you can think the price of that item is infinity, and therefore you can never afford it. So, financial constraints are more than enough to help us. Legal constraint can also be used, that when the government bans an item, you still can have it, but perhaps you will have to pay higher price because they may be available in the black market. So, you will change the price accordingly. So, the point is that the financial way of looking at things is really useful, and it helps us talk about consumption feasibility set. We have been talking about end goods, but end goods are difficult to deal with. We will limit ourselves to two goods. So, one reason is very simple, that it is convenient when your discourse is related to two goods, but complaint you can have that we live in n good world. It is not just we are consuming only two goods. So, it is not realistic what you are talking about, and to them I will say that there is a particular way to look at the world, then you would understand that two goods are enough. Let us say right now you are going to purchase milk. Of course, you are not purchasing all n items together, you are purchasing perhaps one at a time. So, when you are purchasing one at a time, what you are interested in, that item and all other item. So, we can say x1 represents the amount of milk and x2 represents all other item. So, of course, you will have price of milk that you need to worry about, okay, and let us put xm, and then you need to worry about x2. What should be the price of all other item? All other item, the price can be simply in terms of rupee, and that is the money left to buy all other item. So, you can say that it is x2 multiplied by 1, and this should be less than your income. What I am basically, if you are in the two good world and you are interested in only financial constraint, how can you write it? The price of good one is P1. So, how much of money you are spending on good one? P1 x1. How much of money you would be spending on good 2? P2 x2. If price of good 2 is P2 and you are buying x2 amount of good 2. Okay, and this has to be less than your income or the money that you have. So, this is the financial constraint that is very, very important. So, in this financial constraint that we are talking about, you can do here P of milk xm, P2 is going to be leftover money, it is in the rupee term. So, its value is for one item it is 1, and x2 is the amount of money that is left to you, and that should be equal to or less than I. So, this is catch all. That could be the logic. Another logic is that economics is all about trade off, as we saw on the production side also, that as price of item inputs, prices of inputs change, you would like to use different combination, because there is a trade off between benefit and cost. So, in economics everything is all about cost and benefit, and therefore, what is important is the trade off between the two items. Okay. If you have 3 items, you will have 3 trade offs. Let us say x1, x2, x3, a trade off between x1 and x2, a trade off between x1 and x3, and trade off between x2 and x3, 3 trade offs. When you have 2 goods, you will have only 2 trade off, but when the aim is to understand the trade off between 2 items, two goods are enough for our purpose, and that's what we are going to do. We are going to limit ourselves to two goods. That's really very helpful. Before we close this video and get into the details of budget set and budget line, let us understand the budget set. So we have here, we said P1 x1 plus P2 x2 is less than or equal to I. For legal constraint, P2 changes. For geographical constraint, P2 can become infinity, but basically that's what you have. And here is x1 and here is x2. So instead of focusing on less than or equal to, first focus on P1 x1 plus P2 x2 is equal to I. We are plotting it into two dimension, that one dimension is given by x1, the other dimension is given by x2. So we can rewrite it as P2 x2 is equal to I minus P1 x1, or x2 is equal to I by P2 minus P1 by P2 x1. So this is our intercept. This is our vertical intercept. If you remember your coordinate geometry, then you should be able to identify that this is equation of a line. This is 0 and this is I by P2. If you further probe, and that I am not going to tell you right now, if you have a problem you will ask us during live session to go over a bit of coordinate geometry. This is horizontal intercept and this is equal to I by P1, and the slope of this line is going to be minus P1 by P2, and this line divides the positive non-negative orthant into two parts. One part is here, in this part P1 x1 plus P2 x2 is greater than I. On this line P1 x1 plus P2 x2 is equal to I, and in this part, the shaded part, P1 x1 plus P2 x2 is less than or equal to I. So this shaded zone is our budget set. Budget set is just, we are saying we are calling it by name feasible set or consumption feasible set. When we use consumption feasible set, it includes all different kind of constraint, legal, financial, geographical and many more. When we are saying the budget set, what we mean that we are talking about financial constraint. But as we have already talked about that financial constraints are good enough to discuss all other constraints. So we have budget set, and the boundary of the budget sets are three lines. One is where on this line x2 is equal to 0 and then x1 is equal to 0, and the budget line where P1 x1 plus P2 x2 is equal to I. So this is what you get as the budget set. Although we are limiting ourselves to 2 dimension only, but one can easily get into 3 dimension. 4 dimension would be difficult. 3 dimension at least you can visualize that there are 3 dimension x1, x2 and x3, and then you will have this, something of that sort, and this will be the budget surface, and everything included within that is going to be part of your budget set. But 2 dimension is very clean, it's much easier to understand, and therefore we will stick to 2 dimensional budget set and budget line. That is good enough for us. In the next video, we are going to explore this budget set and budget line in way more detail. Thank you.